Good afternoon, everybody. My name is Egil Vedlog. I'm design manager for merchant ship technology in Rolls-Royce, and we are based in the northwest coast of Norway, and we have a lot of gas. So that's not a problem there, I can assure you. I'm sorry, not speaking Italian, but I suppose it's better with English than Norwegian. So I continue in English. I think to have optimal vessel performance, you need to combine technologies to get lowest possible fuel consumption and maximize the emission reduction. And that's exactly what we're doing with the EnvironShip concept. We are combining innovative Rolls-Royce technology and put it into a system and make sure it functions optimal together. This is an award-winning concept. We are the owner of the Next Generation Ship Award, and for 3 weeks ago we did win the Green Ship Technology 2013 award at the Green Ship Technology Conference in Hamburg. We are also nominated to the Ship of the Year this year at the North Shipping exhibition in Oslo in June. On the slide you can see also, I think it's David Cameron as well. I'm not sure how much you know about Archimedes' law, but he really liked the concept. This concept is based on mainly 5 technology pillars. It's the Rolls-Royce piercing technology. It's the Rolls-Royce hybrid shaft generator system. It's the Rolls-Royce gas engine and the gas fuel system. And it's the Rolls-Royce ProMAS integrated rudder propeller system. And the 5th pillar is the design and engineering, where we take care of that all these systems work optimal together and that the technical logistic interface has been taken care of. I will just, I don't think we have it, normally I use 1 hour on this presentation, but I suppose I have to speed up, so I will just quickly go through briefly go through the technical advantages by these 4 technologies. We have the Rolls-Royce ProMAS system, which is basically an integrated propeller. It's a hubcap, it's a rudder bulb, and it's a rudder. And by having this hubcap and the rudder bulb, you take away the hub vortex behind the propeller, and then you are more free to do an optimal load distribution over the propeller blades. This means that you can move the load on the propeller blades from the propeller tip closer to the hub. This increases significantly the propeller efficiency, and it takes also, or reduces significantly the possible pressure pulses towards the hull, and by that reduce noise and vibration. In addition, we have a twisted rudder, and it's twisted to port side above the hub and to starboard below the hub, and this is to recover the rotation energy in the water behind the propeller. The profile of this rudder is like an airplane wing. Airplane wing is lifting the airplane upwards, but this rudder, instead of upwards, is lifting the vessel in forward direction. This means that this propulsion system altogether gives a performance improvement between 4 to 8%. We have done quite extensive testing to demonstrate this and benchmarking as well, so we know that this works. The next technology pillar is our gas engines. We have been in the gas engine market since in mid-60s with land-based power plants, and now we have developed these gas engines into a 2nd generation marine application. This is a spark ignition lean burn technology, combustion technology. It's a very robust and polite technology. It's basically a spark plug and a pre-chamber and a main chamber, where the spark plug ignite the pre-chamber, which again ignite the main chamber of gas in the combustion process. This gives very quick load response when you have dynamic load from the propeller when you're moving in a real seaway, and also quick when you increase the power quickly. Okay, there we are. This is a purpose-built gas engine. That means there are no compromise. It's built to go on only gas. This means that also we have a very low methane release through the exhaust system. And so we have a very high thermal efficiency on the engine. It's over 48% thermal efficiency compared to conventional diesel engines where you are down between 40 to 44. So this makes it a very fuel efficient engine. And the NOx emission is also very good. We are reducing the NOx emission with more than 90% without extra equipment. The same is with the sulfur. In methane there are no sulfurs, so it's very close to 100% reduction on the sulfur. The only sulfur you get out is from the lub oil you use. And the same is with particulates. The only particulates that generates comes from the lub oil. So it's a very clean fuel. And the CO2 reduction through this engine is also over 22%. So without extra equipment in the engine room, with this gas engine you fulfill the Tier 3 IMO Tier 3 requirements. You can see on the slide that there is some green spots below the Tier 3 limitations. That 2 spots is our 2 gas engine ratings. We have 35 bore gas engines, B engine, and we have the C26 bore engines with ratings up to 7,000 kilowatt. You can see the graph, the blue line on the graph. That's the fuel consumption. That's the fuel consumption over power. So you can see it's a very flat fuel consumption curve, all the way from 100% load down to 20% load. This means that this engine do have better performance fuel consumption wise than auxiliary engine, for instance. I'll show you later on the hybrid shaft generator presentation. We have done some comparison with dual fuel engines also as well when it comes to fuel consumption. We see that on 100% load there are more than 7% difference in fuel consumption. And if you go down to 50% load, you see that it's all the way up to almost 17% difference in fuel consumption. The gas fuel system is also very simple, and like in this system, we take, in an environship concept, we take responsibility from the bunker flange to the propeller thrust. So we also have incorporated in our supply the gas fuel system, and it's based on the IMO C tank pressurized tank type. In front of this gas tank there is what we call a tank connection room, and that's the process room where you process the gas in front of the engine. And you use the cooling system from the engine through a secondary glycol system to vaporize the gas. There is a pressure build-up unit which build up the pressure in the tank, and no pump, so the gas flow right into the vaporizer, which makes sure that the engine gets gas and also right pressure and temperature at any time. Yeah. Okay, the next technology pillar is the hybrid shaft generator, and this is for optimal operation. Conventional solutions or traditional solutions are with fixed RPM on the engine and the propeller. Then you will have a lot of rotational losses on the propeller. That's history. Now we have the hybrid shaft generator, which makes able to still keep the shaft generator connected, even if you take off RPM on the engine and you reduce RPM on the propeller. This means that when you are loitering or going or lower speeds, you can run combinator and you can follow the propeller curves and save a lot of fuel. This hybrid shaft generator makes also possible to have different operational modes. You can boost with the auxiliary engines through and use the shaft generator as electric motor, or you can run gas or diesel electric with the auxiliary engines, where you also use the shaft generator as a motor, and you can do maintenance on the gas engines, or you can move the vessel by diesel electric system. So there is a full redundancy on the propulsion system with this solution. Then we have the last pillar in this EnviroShip technology, which is the wave piercing technology. Here we have had the focus to optimize the vessel's performance in a seaway without compromising the calm water performance, underwater calm water performance. It's basically increasing the length beam ratio to reduce the resistance, and we have also taken away flare in the bow and have straight sections in the bow, which also reduce the swell up around the bow. And this has been extensively tested and benchmarked, and we see that we are reducing the resistance in the seaway with more than 10%. This is a patented solution by Rolls-Royce. Okay, summary. ProMOS, the EnviroShip concept consists of a ProMOS, increased propulsive efficiency and improved maneuverability. Rolls-Royce gas engines, improved efficiency and less emission. Hybrid shaft generator, optimal vessel operation. And we have the Rolls-Royce wave piercing technology, less resistance, speed loss, and accelerations in a seaway. We see that this combination of these technologies gives us more than up to 40% CO2 emission reduction compared to conventional solutions. And this is a very flexible arrangement. It can be used over almost towards every kind of vessels. And we use it for all our product portfolio. Thank you very much.
Grazie.